Dear students, before watching my class, set your video quality to high resolution as shown. Hello. In my last class, we have discussed regarding the last bit of interhalogen, that is AX type of compound, particularly iodine heptafluoride molecule. There we have studied the preparation, properties, hybridization and structure of iodine heptafluoride. So today I am going to deal with the another important bit, that is pseudohalogens. Coming to the pseudohalogens, which is the last bit of the inorganic chemistry syllabus belonging to third semester, that is pseudohalogens. In pseudohalogens, we have to see the introduction regarding the pseudohalogens, definition of pseudohalogens, then we have to see what are the pseudohalogens, preparation, properties and structure of different types of pseudohalogens such as cyanogen, oxycyanogen, Thiocyanogen and Selenocyanogen. So in pseudohalogens we have to see totally 4 types of pseudohalogens, that is cyanogen, oxycyanogen, selenocyanogen and thiocyanogen. A molecule consisting of 2 or more than 2 electronegative atom which resembles the halogens, but they are not a real halogen atoms, but they behave as a halogens, are called as pseudohalogens. That is, pseudohalogen means a molecule consisting of 2 or more than 2 electronegative atoms which resembles halogens, but they are not a real halogens, but they behave as halogens, and such molecules or a group of ions are considered as a pseudohalogens. Coming to the definition of pseudohalogens, here Kellerman and Brickback has defined and studied regarding the various type of pseudohalogens, their preparation, properties as well as structure. So according to Brickback and Kellerman, the pseudohalogen is defined as a large number of inorganic radicals which in free state possesses properties similar to those of elemental halogen, and in the form of an anion possesses the properties similar to those of halide ions. So according to Brickback and Kellerman, the pseudohalogens are defined as a large number of inorganic radical which in the free state possesses properties of elemental halogen, and in the form of an ion possesses the properties similar to those of halide ions. For example, chemically free molecules such as CN2, that is cyanogen, OCN2, Oxycyanogen, SCN2, Thiocyanogen, and SECN2, Selenocyanogens. So these are the various examples of the pseudohalogens. The pseudohalogen ions corresponding to the pseudohalogen molecules. For example, for cyanogen CN2, corresponding ion is cyanide ion, that is Cn minus. Coming to the oxycyanogen, its corresponding ion is oxycyanate ion. Coming to the thiocyanogen, thiocyanogen corresponds to thiocyanate ion, that is SCN minus. Likewise, SECN minus corresponds to the selenocyanogen, that is selenocyanate. So these are the corresponding pseudohalogen ions. Then coming to the what are pseudohalogens? There are several uninegative groups which shows certain characteristic properties of halide ions. Such groups are called as pseudohalides. For example, Cn minus, OCN minus, SCN minus, and coming to the particular, that is what are pseudohalogens. There are several uninegative groups which shows certain characteristics of halide ions. Such groups are called pseudohalides. Coming to the what are pseudohalogens. There are several uninegative groups which shows certain characteristics of halide ions. Such groups are called pseudohalides. For example, Cn minus, OCN minus, SCN minus, SECN minus, etc. Coming to the first type of pseudohalogen, that is cyanogen. Regarding the preparation of cyanogen. Cyanogen is obtained by heating silver cyanide alone as shown. That is 2 moles of silver cyanide. On heating, it forms cyanogen with the formation of free silver. That is, cyanogen is obtained by heating silver cyanide alone as shown. That is 2 moles of silver cyanide. On heating, it gives cyanogen with the formation of free silver. Coming to the second method of preparation of cyanogen. Cyanogen is also prepared by heating a mixture of mercuric cyanide with mercuric chloride. That is, cyanogen is also prepared by heating a mixture of mercuric cyanide with mercuric chloride as shown. That is 1 mole of HgCN2 and 1 mole of HgCl2. On heating, it forms cyanogen with the formation of mercurous chloride, that is Hg2Cl2. Coming to the properties of cyanogen. Here we have to see both the physical and chemical properties of cyanogen. So coming to the physical properties, cyanogen is a colorless gas. It is soluble in water and it is poisonous in nature. On cooling, cyanogen at minus 21.2 degrees Celsius, it condenses to a liquid which on further cooling at minus 27.9 degrees Celsius, cyanogen freezes to a solid. On heating, cyanogen gives insoluble para-cyanogen. Cyanogen on heating, it gives insoluble para-cyanogen. That is 1 by 2 n moles of cyanogen on heating, it gives cyanogen n moles, and Cn n times itself is called as a para-cyanogen. Coming to the chemical properties, cyanogen is fairly stable in water, but its alkaline solution decomposes to give cyanide ion and oxycyanate ion. Then coming to the structure of cyanogen. The following structure indicates the cyanogen molecule, that is Cn twice. The bond length between carbon and carbon in a cyanogen is 1.39 Armstrong units, and the bond length between carbon and nitrogen is 1.16 Armstrong units. Here in the structure, the values are represented in picometers, and at the bottom of the structure, here I have mentioned the bond length between carbon-carbon as well as the bond length between carbon and nitrogen in terms of Armstrong units as well as picometers. Coming to the second type of pseudohalogen, that is Oxycyanogen, OCN twice. Coming to the preparation of Oxycyanogen. Oxycyanogen is prepared by heating silver cyanate with iodine in carbon disulfide media. That is, Oxycyanogen is prepared by heating silver cyanate with iodine in presence of carbon disulfide media at low temperature. That is 2 moles of silver oxycyanate in presence of iodine under carbon disulfide media, it gives rise to Oxycyanogen, that is OCN, twice oxycyanogen with the formation of silver iodide. Coming to the properties of oxycyanogen. Again, coming to the physical properties, oxycyanogen is a colorless gas. It is soluble in water. Again, it is poisonous in nature. On cooling, condenses into liquid. Further cooling, it condenses to a solid. Coming to the structure of cyanate ion. The following structure indicates the oxycyanate ion structure. Then coming to the structure of cyanogen. Here OCN twice is represented as NN single bond bonded with the carbon with a double bond, and carbon is again bonded to oxygen with a double bond. So here the structure shows oxycyanogen and it is a linear structure. This is the linear structure of oxycyanogen. Coming to the third type of pseudohalogen, that is Thiocyanogen. SCN twice. Coming to the preparation of Thiocyanogen. Thiocyanogen is prepared by the action of bromine on silver sulfocyanide suspended in ether. That is, Thiocyanogen is prepared by the action of bromine on silver sulfocyanide suspended in ether media. That is, 2 moles of silver sulfocyanogen in presence of bromine under ether media, we are going to obtain Thiocyanogen, that is SCN twice, Thiocyanogen, with the formation of silver bromide. The reaction is represented as 2 moles of silver sulfocyanogen treating with bromine under etherical media. It forms Thiocyanogen, that is sulfocyanogen, with the formation of silver bromide. Coming to the properties, Thiocyanogen is a yellow solid. It polymerizes irreversibly at room temperature to give a brick red material. Thiocyanogen polymerizes irreversibly at room temperature to give a brick red colored material. It is insoluble in water. Coming to the chemical properties, particularly a oxidizing property of Thiocyanogen. Coming to the chemical properties of thiocyanogen, particularly a oxidizing property. Thiocyanogen oxidizes iodide to iodine. That is, thiocyanogen SCN twice on treating with 2 moles of potassium iodide. So here potassium iodide gets oxidizes to iodine with the formation of potassium sulfocyanide. A free iodine is liberated, forming potassium sulfocyanide, and it also oxidizes cuprous ion to cupric ion. That is, when thiocyanogen is treated with 2 moles of copper sulfocyanogen, it gives rise to 2 cupric ions, that is 2Cu plus 2, forming 4 thiocyanate ions. It also oxidizes hydrogen sulfide to sulfur. That is, thiocyanogen treating with hydrogen sulfide, it gives rise to a hydrogen proton, free sulfur, forming 2 thiocyanate ions. That is, SCN twice treating with H2S, it forms a proton, free sulfur, forming thiocyanate ion. Coming to the structure of both ions as well as pseudohalogen, that is thiocyanate ion as well as thiocyanogen. The above structure shows thiocyanate ion with a minus charge, whereas this structure shows the thiocyanogen, that is SCN twice. Coming to the fourth type of pseudohalogen, that is selenocyanogen, SECN twice, selenocyanogen. Coming to the preparation, selenocyanogen is prepared by heating the corresponding lead 4 salt, that is lead selenocyanate. On heating, it gives lead selenocyanogen and selenocyanogen. Selenocyanogen can also be prepared by the action of iodine on silver selenocyanate as follows. That is, 2 moles of silver selenocyanate treating with iodine, it forms selenocyanogen with the formation of free silver. Coming to the properties of selenocyanogen. Selenocyanogen is a yellow crystalline substance. Selenocyanogen is a yellow crystalline substance which turns to red on long standing. It is quite stable in a dry condition and it reacts with water as below. that is 2 moles of Selenocyanogen with 3 moles of water. It forms HCN, 3 moles of HSECN and 1 mole of H2SeO3. The reaction itself indicates the action of Selenocyanogen with water. Coming to the structure. Here, Selenocyanogen is represented as shown in the following structures. So this is one type of a structure of Selenocyanogen, where 2 moles of Selenocyanogens are bonded with selenium atoms like this. So both the structure indicates the structure to the Selenocyanogen. So in today's class we have studied different type of pseudohalogens, so which ends the topic for the third semester. That is, we have studied regarding the preparation, properties, structure, hybridization and uses of some of the molecules belonging to boron family, particularly borazine, which is called as inorganic benzene, diborane, and also we have studied regarding the interhalogens, especially the types of interhalogens: AX type, AX3 type, AX5 type, as well as AX7 type of interhalogens, their preparation properties, hybridization and structure, and pseudohalogens. So this ends the topic to be covered by myself for the third semester, and whatever the classes conducted by me, the PDF is available in the video description. The PDF helps to the students to get the copy of my whole topics covered. So you can get the PDF in the video description. So thank you, one and all.